what I'm going to do next is this. I have a picture this here, or a perfect pentagon. So I no longer need everything which was above this line. All I care about is this line alone. There are lots of different markings on this picture. I'll explain all of them, hopefully, within the next 4 minutes. But for now, let's just ask a question. What will be the side of this perfect pentagon, given that the pentagon is inscribed into the unit of circle? Here's my unit of circle, radius 1. Angle here, which is facing one of the sides of the pentagon. What's the angle here? The complete revolution is 2 pi, so the angle is 2 pi by 5, isn't it? Or the half of that angle is just pi on 5, half of that angle. Because this is the right angle triangle, the half of the side will be simply sine pi on 5, isn't it? And the whole side will be double of that. Everybody happy with this conclusion? Good. Now, imagine I take my x equals sine pi on 5, because that's the value we're looking for, isn't it? Because that's half of the side of the perfect pentagon. If I take theta here to be pi on 5, sine of that will be 0, isn't it? Sine of 5 times pi on 5. So if I just sub in this value in here, I will come up with a beautiful simple equation which will give me the value for this unknown x, isn't it? This is the left-hand side of my equation. This is the right-hand side, 0. So my theta here is pi on 5. Well, it's a fifth-order equation, but actually it's solvable. It's solvable with the regular high school methods, because we have a common factor x, which gives you one trivial root x equals 0. The remaining equation becomes the fourth-order equation, but with the substitution, because you have only x squared here, basically it's a quadratic equation. If you use the methods which solve the quadratic equations, your x squared will be the expression like this. Negative half of this, plus minus square of the b term, divided by, take 16 times 5, which is 80, divided by 16. This is a value for the x squared. This is just the formula for the solutions of quadratic equation. And that is something like this. Now, the sine itself then will be the root of this expression. It will be the root of this expression. The question to you now goes like this. Is it plus or minus I have to take to find sine pi on 5? Well, I'll give you a hint. You have to take minus. Why minus? You have to take minus for this reason. Listen to this. If you take here, rather than pi on 5, if you take here 2 pi on 5, this is another angle within the first quadrant. 2 pi on 5 still less than pi on 2. So it's another angle within the first quadrant. It's another angle where sine is positive, right? The same argument will still work, right? The sine of 5 of this value will be 0, so the sine of this angle will also be a solution to this equation. So in fact, these two values, if you take the root of these two values, one of them will be sine of pi on 5, and the other one will be sine of 2 pi on 5. And because sine of this one is lower than the sine of this one, you have to choose the one with the minus for the pi on 5. And the one with the plus will go for the 2 pi on 5.